Hi there, welcome to United Visionary Group Symposium Presentation, a new vision of mixed-use developments for the City of Brampton. First, it is only appropriate to introduce the team. Our team, comprised of myself, Tiana, and my colleagues Baljinder, Zach, and Mooney, have been advised by Dr. Chris Bachman over the last 2 semesters. This presentation is organized into 3 main sections: the team's Phase 1 and Phase 2 achievements, and our final conclusions. The City of Brampton is poised for significant short and long-term growth as they continue to combat rapid population increases within the GTA. Constructing traditionally low-density, auto-dependent communities, the city's current development practices have put a large strain on the existing transportation network. UVG was selected by the City of Brampton to create a mixed-use development prototype which combats this problem. The team chose to pursue a site within Brampton's Gateway, an area with existing connectivity limitations and issues, with plans for major future development. The development centers around the construction of the Hurontario LRT, planned for completion in 2024, which will serve as an essential connection from Brampton to Mississauga and Toronto. The selected 8-hectare project site is located on Steeles Avenue, within walking distance to the future LRT's Brampton Gateway Terminal, in addition to the proposed Shoppers World mega development. UVG set out to achieve a total of 4 key objectives. Firstly, UVG believes that to change human transportation behavior, the context of where all transport journeys start and eventually end is a critical component, so the team aims to minimize residential auto vehicle trip generation on site. The next objective was to maximize carbon offset through the incorporation of low-impact development. Next, our third objective involved creating healthy communities within our site. Finally, the team quantified low-impact development and servicing costs. UVG focused on creating mixed-use developments with varying combinations of complementing land uses. The team took the approach of creating thematic alternatives, with each targeting certain objectives to a greater degree. These included a green theme, focused on preserving the natural environment and maximizing green area, a healthy community theme, focused on maximizing public realm and ensuring integration and connectivity throughout, and an intensification theme, focused on maximizing the site area developed. At the end of Phase 1, it was recommended that the City of Brampton adopt the healthy community alternative. Through in-depth research of various City of Brampton documents and programs, it is evident that residents desire a clear sense of belonging in their neighborhoods with an aesthetically pleasing environment, improved transit connectivity, and diverse land uses. Thus, healthy communities are at the forefront of the city.
Welcome to a new vision of mixed-use developments. UVG has designed a 3D model of our planned development to help illustrate the key features which make our site stand out. The major key feature themes include the element of a mixed-use community, public spaces provided to residents, the connectivity and mobility within our development, the interconnectivity between blocks with the grid street pattern followed, and the vibrancy provided to the development with interesting features within blocks. To begin, some of the development's various features can be highlighted. This includes the site's park area, which serves as a way to provide recreational opportunities to residents, as well as target UVG's goal to prioritize green spaces within the community. Along with this, the site includes an urban plaza area, along with outdoor courtyards to showcase connectivity and vibrancy. One of UVG's goals was encouraging an active lifestyle, which is done through the inclusion of multi-use courts along with rooftop patios and amenities such as green roofs and safe gathering areas. Next, let's take a look at how our team prioritized connectivity with features that promote mobility and interconnectivity within the site. To promote different modes of transportation, such as walking and cycling, the team included multi-use trails and sidewalks throughout the site within the road cross-section. There are a total of 4 different types of road cross-sections. First is a main road with a 25-meter right-of-way, which includes a multi-use pathway and sidewalk. Second is the secondary road cross-section, which is a 20-meter right-of-way, including a multi-use pathway and a sidewalk. Also, there are 2 pedestrian promenades at the top right and top left of the development. These pathways provide easy access to Steeles Avenue, located north of the site, for pedestrians and cyclists to easily connect to the Brampton Gateway Terminal. Finally, let's take a look at the mixed-use land uses within our development. UVG's development includes residential, retail, office, and institutional and community floor uses. The floor space index of the site comes in at 2.12, maintaining a good ratio of built to open space. The details for land uses are shown in the graphic. Now, let's take a detailed look at a development from the ground up.
To begin the design for all underground infrastructure, grading was completed using a Civil 3D model based on existing LiDAR data for the site provided by City of Brampton GIS. The grading strategy is shown in this slide, with flow arrows indicating a general drainage pattern from northeast to southwest. The chosen design relies heavily on matching into existing site topography as to minimize cut and fill, and was constrained based on 7 proposed connections to existing roadways and pedestrian infrastructure. Finally, a stormwater management outlet design for major storm events was created with maximum surface ponding depths near the infiltration chambers. Overflow is designed to spill onto Malta Avenue at the west end of the site. Relating to the site's sanitary servicing, UVG first defined all internal building details, including the number of units and the areas of retail, commercial, and office space within. From this, the sanitary system was designed based on guidance from the Region of Peel Public Works Sanitary Sewer Design Criteria. Finally, the system was modeled using a design sheet with 12 catchments. The total flow exiting the system is 60.23 liters per second to an existing 450 mil stub located on Malta Avenue. Overall, the system consists of 16 manhole structures, over 740 meters of 250 and 300 mil pipe, and approximately 520 meters of service laterals. Next, the development's water distribution system will be discussed. To begin, the drawing on the right shows the water distribution plan and subsequent hydrant coverage throughout. Demand calculations have been performed based on requirements within the Region of Peel Public Works water main design criteria as summarized at the bottom of the slide. Fire flow calculations for the site's largest building were also completed using the Ontario Building Code and the Fire Underwriter Survey. Finally, given the 900mm trunk water main present on Steeles Avenue, UVG has assumed the listed demands can be adequately provided, however, understands this would need to be confirmed with the region. Additionally, an internal network would need to be completed to ensure adequate water pressure throughout the development. For storm servicing, the system was designed based on guidance from the Region of Peel Public Works Storm Sewer Design Criteria. The design considers 52 catchment areas created based on the grading plan and includes consideration for an external 2.2 hectare grassed area currently draining onto the site. Storm sewer design sheets were created for the development based on 10-year and 100-year storm events. Overall, the system consists of 52 various structures and contains over 1.2 kilometers of sewers. The site's infiltration chamber system is designed to provide 3,000 cubic meters of storage, in addition to the 700 square meters of proposed green roofs.
Next, UVG has chosen to implement LID technologies into the proposed development in the form of green roofs, curb inlets, and an underground stormwater infiltration system. To guide the design of LID technologies, the Sustainable Technologies Evaluation Program STEP wiki was used. As seen on the right of the slide, initial servicing costs total to approximately $6.7 million. On the left of the slide is a summary of the lifecycle cost analysis that has been complete for the green roofs. These results have been provided to be transparent with the full asset management cost to the city. Now let's transition to grade level to discuss the transportation feasibility of the site.
UVG completed a traffic impact study for the proposed development to ensure the existing road infrastructure in the vicinity of the site can sustain the development-generated traffic in the 2026 horizon year. UVG analyzed operations at 14 intersections, as shown on the right-hand side, during the weekday AM and PM peak hour and Saturday peak hour. The analysis was completed for 3 scenarios: existing conditions, representative of 2019 pre-COVID traffic levels; future background conditions, representative of traffic levels in 2026 pre-construction; and finally future total conditions, representative of traffic levels in 2026 with the site built and occupied. The existing traffic volumes shown on the right-hand side are based on traffic count data collected in May 2019 by Spectrum Traffic Data and made accessible to UVG. Next, future background traffic volumes are forecasted, which consist of existing traffic volumes in addition to traffic generated by background developments, growth in traffic levels along corridors based on historic count data, and lastly, an adopted reduction along the Hurontario Main Street corridor to capture the effects of the Hurontario LRT on mode choice changes and redistribution of traffic to alternate routes. The vehicle traffic projected to be generated by the site was determined based on a combination of trip generation rates from the IT Trip Generation Manual and review of trip generation rate data for development sharing a similar transportation context as the proposed site. The resulting vehicle trips were then adjusted to account for interaction between proposed mixed land uses, future Brampton mode share forecasts from their transportation master plan, and lastly, pass-by trips expected for the retail uses. The development is forecasted to generate 1,075, 1,230, and 1,195 two-way vehicle trips during the weekday AM, PM, and Saturday peak hour, respectively. Next, the forecasted vehicle trips were assigned onto the local road network for each land use based on prevailing traffic patterns and trip distribution analyses completed using 2016 TTS data. Finally, the future total traffic volumes were determined by adding the site-generated traffic volumes onto the future background volumes. The resulting projected volumes were used for modeling purposes. PTV Vistro 2020 using the Highway Capacity Manual methodology was used to model and analyze all 14 study area intersections during the peak periods for all three scenarios. The volume to capacity ratio indicates the capacity utilization for each movement at an intersection. A V over C of 1.0 for a particular movement indicates that that movement is operating at its theoretical capacity. As an example, the future total AM scenario modeled on PTV Vistro is shown on the right-hand side, with the V over C ratio for each movement shown at 3 intersections. Through the modeling process, UVG determined that 6 intersections would require minor signal timing updates, in particular phasing changes. After making the timing updates, UVG verified that all movements at all intersections in future total conditions are expected to operate at a V over C below 1. As such, UVG can conclude that the existing roadway infrastructure and geometry can adequately sustain the traffic generated by the proposed development and continue to operate at acceptable levels in 2026.
UVG has been committed to bringing the vision of a high-quality, vibrant, and connected community to life within this transit-oriented neighborhood. Tremendous focus was put into developing an active community that encourages alternate modes of transportation through diverse land uses. Ultimately, UVG imagines a 15-minute neighborhood, bringing essential amenities to residents' doorsteps, minimizing residential trip generation. The development innovatively utilizes LIDs to maximize carbon offset and boasts a healthy community with indoor and outdoor opportunities for social gatherings and wellness. Overall, the development will act as a vein to facilitate the nearby Hurontario LRT to act as the heart of the Brampton Gateway area.